All right, welcome to Chapter 2, Properties of Real Numbers. As always, you want to make sure that you have out your pencil and paper because you will have some stuff to turn into me. A lot of things going on in this chapter. We'll talk about, today we're just going to talk about numbers, comparing them, graphing them, the opposites, absolute value of numbers, those types of things. We'll also get into operations, adding, subtracting, multiplying, and dividing. And all of this is with real numbers. So if you take a look at the graphic to your right, all of these are considered the real numbers. And there's this whole other subset of numbers called imaginary numbers that many of us probably haven't worked with yet. But everything you've done up until this point has really revolved around real numbers. So section 2.1, today we'll be focusing on the number line. So what exactly are real numbers? Well, the set of numbers that include whole numbers, and you guys remember whole numbers from your early days of elementary school. So we got the whole numbers. We got the integers, which remember are the whole numbers and their opposites. So 7 is a whole number. The integers would include 7, but it would also include -7. Okay. Well, where does that leave the fractions and decimals? Well, fractions and decimals kind of fall under this category of rational numbers. So hopefully in 7th and 8th grade you talked about rational numbers versus irrational numbers. And those are two different subsets of real numbers that cover a little bit more ground. And to kind of give you just a quick review, rational comes from the word ratio, ratio meaning fraction. So rational numbers can all be written as fractions. Okay, for example, let's say we had 3/4. It's a fraction, that'd be a rational number. Even a number like 7, you could write 7 as a fraction, 7/1. Even a number like the square root of 36. Right? Square root of 36 is 6. 6 can be written as a fraction, so that's considered a rational number. 1.2 can be written as 1 2/10. It can be written as a fraction. And even those repeating decimals, like 0.3 repeating, 0.3 going on and on forever, but it has a repeating pattern, that could be written as 1/3. So anything that can ultimately be written as a fraction is a rational number. So what are the irrational? Well, you can kind of sense this idea of opposite there. So the irrationals are opposites to the rationals. They cannot be written as fractions. And these are numbers that go on forever and never repeat. They go on forever and they never repeat. So a good example of an irrational number would be pi. Pi is a decimal, 3.14, and then it has a bunch of other stuff behind the 0.14. And this number basically goes on forever to infinity and never hits on any kind of repeating pattern. Other common irrational numbers are what I call the funky square roots. So like square root of 2. Okay, we knew what the square root of 36 was. It was 6. But square root of 2 doesn't really simplify into anything as nice. Or even something like the square root of 17. Okay, you probably couldn't tell me what the square root of 17 is. Well, you can't. It's a decimal. And it's a decimal number that goes on forever, and it does not have a repeating pattern. So those are the types of numbers that we mean when we're talking about rational and irrational. Okay. Also want to point out here on the number line, you know this, but 0 is also called the origin. And I know that you guys are used to using the origin on a coordinate plane, but the number line is really like the x-axis in a coordinate plane. So 0 is sort of that middle value, call it the origin. Anything to the left of 0 will be the negative numbers, and anything to the right of 0 will be the positive numbers. Okay, so go ahead and get that pencil and paper out. You do need to copy down this number line, and I have not completed mine yet. But we're going to graph these numbers. and I've given you 6 numbers: square root of 19, pi, negative 3/5, 23 over 8, 0.7, and negative 4/9. And what I want you to do is, let's get this number line running out to maybe like 5, let's say. So we can put some hash marks. Try to do your best to make them equidistant if you can. And we're going to try to locate some of these numbers. And I want you to go ahead and do yours first. So go ahead and copy the number line, and I want you to place the location of these numbers using a closed circle. So when you graph on a number line, you're going to draw in a little closed circle and then write the number either above or below. So go ahead and try those on your own first. Hit pause now. Okay, let's go ahead and begin with the square root of 19. You probably don't know what the square root of 19 is. I don't either. It's because it's one of those funky square roots. It's an irrational number. But what we do know is that the square root of 19 is somewhere in between the square root of 16, which is 4, so I'm putting it under the 4 location, and the square root of 25, which is 5. Okay, and square root of 19, if I had to choose where it's going to lie, is it going to be closer to radical 16, or is it going to be closer to radical 25? Well, it's going to gravitate toward the radical 16. So when I place this guy, I want to place him closer to the 4 than I do to the 5. So I might decide to put radical 19 about right here. Okay, our next number is pi. We know that pi is approximately 3.14, not exactly, but approximately. So that's going to be in between the 3 and the 4, closer to the 3. So I might locate pi right around here. All right, negative 3/5, that's a number that's on the left of the origin. Once again, the origin right here, we're going to the left of the origin. And kind of the question is, are we going to put this closer to the 0 or closer to the -1? And we might want to add in a little halfway mark here. There we go. So will we put the negative 3/5 to the left of that halfway mark or to the right of that halfway mark? And that's really the question you need to answer. It should be to the left, because that's negative 0.5 at the halfway mark. Negative 0.6 is negative 3/5. So somewhere around here. And then we want to just go ahead and label that negative 3/5. Okay, 23 over 8. Now that number is close to 3, because 24 over 8 would be 3 itself. 23 over 8 is a little bit less than 3. So we might locate it about right here. 23 over 8. 0.7 is a number between 0 and 1, and it gravitates toward the 1. So I'm going to put it a little bit closer to the 1. So I might put 0.7. And then lastly, negative 4/9. This one's really close to negative 3/5, but it does not cross the halfway mark. That's really negative 0.4 repeating. So we're going to put it to the right. It's actually closer to the 0. We're going to put it to the right of that halfway mark. So negative 4/9. Okay, when I grade you on this stuff, I will look for your ability to place the points in a precise location. We call that process interpolation. In other words, you're kind of guessing where a value lies in between two other values. You are interpolating. Okay, and that's a skill that you will need throughout the year. Okay, let's move on to something else. I think you'll find this a little bit easier. Example 2, we want to put the following numbers in ascending order. What does ascending order mean? Well, that means increasing order. So go ahead and take a look at those 6 numbers, and you want to put them in order from least to greatest. Go ahead and do that on your paper now, and you can hit pause. Okay, so the numbers on the left are going to be the ones that are less than the numbers on the right. So when we start in increasing order, we kind of want to find the number that is considered to be the least. And for this list, that's going to be negative 2.6. So that should be hopefully the first number you've written down. Now the next number in order as we kind of approach 0 is going to be negative 0.1. That one's not very far from 0 at all. And then the next number on our list, you might have sort of a competition here between 4/7 and 0.4. That might have given you a little bit of pause. And if it helps, take the fraction and maybe convert it to a decimal. You could type that into your calculator, 4 divided by 7. It's going to give you 0.5714, I think, something like that. But you don't even need a calculator. You can just think about the two numbers. 0.4 is less than a half. 4 out of 7 is greater than a half because we know that 3.5 is half of 7 and 4 is bigger than that. So the smaller one's going to have to come first. That's going to be the 0.4. Followed by the 4/7. Okay, and then our last two numbers, we have a competition between pi and square root of 16. Now we know that radical 16 is 4, pi is a little bit closer to 3, so pi is going to be less than that number. So pi and then radical 16. So this task is actually a little bit easier than graphing them on the number line. Okay. All right, let's talk about opposites. You know, this is a really interesting definition for opposites. Usually when we think of opposites, you might just think of like the negation of the number. So if it's 5, the opposite is -5. Or if it's -7, the opposite is 7. Kind of like a multiplying by -1 deal. But this is more of a geometric definition. It says to be opposites, the reason things are opposites is that they are the same distance from the origin, or they are the same distance from 0. So I think we all know that the opposite of 3 is -3. But the reason is because both of those numbers happen to be the same distance from 0. Another concept that deals with distance from 0 is absolute value. And hopefully you remember this one from middle school. The absolute value of a real number is the distance the number is from the origin. So we define that as distance from the origin, or distance from 0. Okay, so whatever a number's distance from 0 is, that is considered to be its absolute value. Okay, for example, here we have the absolute value of -5. How far is -5 from 0? Well, it's 5 away from 0. The absolute value of 5, okay? How far is 5 away from 0? Well, it's 5 away from 0. Pretty easy. Okay, and then here we have the absolute value of 0. 0 is 0 away from 0, so its absolute value is 0. Pretty simple, okay? We might have been taught or might have learned it this way, that absolute value is always positive. It is true that anything inside the absolute value bars will turn to a positive number, but that does not mean that your answers to absolute value problems will always be positive, and you'll see what I mean here in a second. Okay, so go ahead and get back out that paper, and we're going to do some absolute value examples that I want you to explore on your own first. Okay, and I'm going to give you 4 of these to do by yourself. You can go ahead and copy them down, and then we will go over the answers together. Okay, so go ahead and copy these with me. The first one is going to be the absolute value of 4. So I'm going to want you to tell me what that is. The next one is going to be the absolute value of -4. The next one, and I'm just going to write this one down because I actually want you to interpret what it means for yourself. Obviously, we'll go over that, but I want you to think about what it is yourself first. And here's the last one I want you to interpret. Okay, so go ahead and I want you to try to come to terms with these on your own, find the absolute value, and then go ahead and simplify all of these expressions. Go ahead and hit pause now and do these on your own. All right, well, let's see what we came up with. Number one, the absolute value of 4. Well, how far is this number from 0? It's 4 away from 0. So the absolute value of 4 is just 4. Okay. On number 2, the absolute value of negative 4. Well, how far is negative 4 from 0? It's 4 away from 0. So the absolute value of negative 4 is also 4. Now, number 3, this would be pronounced the opposite of the absolute value of 4. And you have to follow order of operations here. So the absolute value of 4 is 4, and then we're going to take the opposite of that. So what's the opposite of 4? Well, that's negative 4. So here we have negative 4 as an answer. You're doing the absolute value of 4 first and then negating it. Same thing down in number 4. We do the absolute value of negative 4 first, and we get a 4. And then we're going to take the opposite of that 4. Okay, so the opposite of 4 is negative 4. Make sure you understand the reasoning behind all 4 of these, and if you have any questions, be prepared to ask me in class tomorrow, because you'll need to know this. All right, now let's move on to something a little bit more complex. For your last 3, we're going to get a variable involved here. Okay, so I want you to go ahead and copy these down and then try them on your own. Number 5 is going to be the absolute value of x equals 12. And I want you to tell me what x equals. Okay. Number 6, very similar, the absolute value of x equals 9. And I want you to tell me what x equals. Okay. And then number 7, the absolute value of x equals negative 6. And I want you to tell me what x equals. And I want you to try that on your own first. So go ahead and try those yourself. Hit pause now. And then when you're done, let's go ahead and go over them together. Okay, so I am trying to trick you a little bit here. In number 5, it says the absolute value of what number is 12. Okay, most of us probably at least have 12 here, but there's another answer. Okay, this actually has 2 answers. So can you think of another number that would also have an absolute value of 12? In other words, what other number is 12 away from 0? And that other number happens to be negative 12. So when you're listing 2 numbers there, you do want to use a semicolon. If you just put a comma, it kind of looks like an ordered pair. So get in the habit of using the semicolon there. All right, the absolute value of x equals 9. Very similar. What 2 numbers have a distance of 9 away from 0? Well, one of them is obviously 9, and the other one is negative 9. Okay, now number 7, hopefully you struggle a little bit on this one. The absolute value of what number is negative 6? This is a trick question because you can't have a distance of negative 6 from 0. Okay, distance in absolute value sense is always positive. So there's no number that you could plug in for x that's actually going to end up producing a negative 6. If you plug in a 6 here, the absolute value of 6 is just positive 6. Even if you were to plug in a negative 6 here, the absolute value of negative 6 would still be positive 6. So there's no number you can plug in for x. So this is just no solution. And hopefully you were able to figure that out on your own. All right, good job. One more task. You will want to do this on your pencil and paper as well. Go ahead and read this statement about counterexamples. Okay, so in order to prove a statement is true, it must be shown that it is true for all examples. To prove that a statement is false, it only needs to be shown that one example is false. This is known as a counter example. Okay, so what I'm going to do is I'm going to give you some statements. I want you to determine if they are true or false. And here's the deal. You have to have a reason for your answer. Okay, so if you're going to say that something is true, you need to be able to provide an example. If you're going to say that something is false, you're going to need to be able to provide a counter example. Okay, so on your paper right now, I want you to go ahead and copy these down. True or false? Write down both statements. Number one, the opposite of a number is always negative. Okay. Number two, the expression negative a is sometimes greater than a. Okay, go ahead and copy those down, and then I want you to tell me, are these true or false? And then be prepared to give your defense or give your reason. So go ahead and hit pause. Think about that now. And then when you're ready, unpause and we'll go over answers. All right, so let's see what both of these are, and then we'll go into explanations of both. Okay, so number one, the opposite of a number is always negative. That ends up being false. Number two, the expression negative a is sometimes greater than a. That ends up being true. All right, let's go over reasons why. Let's begin with number one. The opposite of a number is always negative. Well, can we think of a number where maybe that's not the case? If I pick any positive number, like 5, yeah, the opposite is negative 5. But what if I began with a negative number? Like, for example, let's say I began with a negative 2. The opposite of negative 2 is a positive 2. So that's showing you an opposite that's positive. I only need to come up with one counterexample, and it makes the whole thing false. So coming up with that counterexample, that's why number one can be false. All right, let's see if we can understand number two. The expression negative a is sometimes greater than a. So in order for that to be true, you kind of have to at least prove it once, because it uses a kind of a wishy-washy term sometimes. Can you think of a number for a that would make this true? And the deal with this guy is you can pick any negative number you want. For example, negative 7. Okay? If we said that a were equal to negative 7, right, then think about what negative a is. That would be negative 7. And we know that the opposite of negative 7 is actually a positive 7. And a positive 7, okay, would be greater than the negative 7. And that's how that one could end up being true. So for that, sometimes you would just have to find one example to support it. Okay, kind of a dense lesson tonight, but I think that you'll find the assignment rather easy as long as you stuck with the video and you understand what it is that you need to know. Good job.